Hi, my name is Carlos Ruiz, and along with my partner David Romero, we will be giving an introduction overview about the Addigy4 project.
This project is divided into two sub-projects. One of them is called Tunneler.
and the other is called PubSub.
For Tunneler, we try to simplify the complexity of creating a remote control session as it is a complex and not practical process for users that don't have technical experience.
Sending messages to multiple devices can prove to be a challenge, though there are a number of methods, not all may be scalable. In addition, there are very few services which keep track of who's entering and exiting a channel, and those that do are usually paid services such as PubSub. As such, we need a cost-efficient model that will be scalable and easy to use. Here we see a breakdown of how time was allocated throughout the sprints, each broken down into 2 weeks. In Sprint 1, we spent time familiarizing ourselves with the technologies we'd have to work with, including languages. In the rest of the sprints, we were allocating time to completing a number of features, bug fixing and refactoring. The documentation itself was drafted throughout the sprints, chronicling each new design change, implemented feature, and test. It should be noted that the time allocated to stories include testing. The following are some of the user stories created in this development cycle. Each of these user stories depicts a different feature or refinement of a feature.
Let's look at two use cases from the Tunneler software. The name of use case 1 is starting a client. The actor is the user. The precondition for the use case is that the software is installed in the system and the terminal must be open. The postcondition will be the running software after entering the right parameters. A scenario is simply the user on the terminal entering the command and location to start the client software. The exit condition will be waiting for incoming connection and possible exceptions or missing parameters if not given. Now for use case 2, the name is start communication. Again, the actor is the user. The precondition is that the client software, server and tunneler must be running. Postcondition is that communication is starting and awaiting for commands. Simple scenario that goes as follows. User opens terminal in case he or she wants to create an SSH session and connects to where the local client is listening. Exit condition, client connects to server and terminal waits for further commands to be executed on terminal. Exception could be that the desired tunnel ID doesn't exist.
The following are two of the main use cases for PubSub. Use case 3 highlights a user's ability to successfully publish a message to a queue. As we can see, before any sort of communication between client and server, a connection must be established. Upon success, the message published will be available to a specified queue, with any message sent to a non-existent queue being dismissed. Use case 4 discusses the ability to subscribe to a queue. Much like publish, a connection must be established between the client and the server. After a successful subscription, the user will continuously receive updated messages from the desired queue until an unsubscription request is sent or cancellation.
The sequence diagram we see is for use case number 2 for the Tunneler software. In here we can observe how the user will start by opening the browser or the terminal. At that point, it will connect to a client where the client is listening to a specific port. Then this client is going to go ahead and connect to a server, creating a handshake where it's going to pass the parameters. The server then it will connect to a desired tunneler and it will give the parameters that were given by the client software. At that point, the tunneler on the other end, it will connect to a target software, meaning a web host, SSH, or VNC remote control software, and the data request is going to be sent back through the server to the client which started the session.
Here we see a second sequence diagram that follows use case number 2. After the connection has been established and the client software is successfully connected with the tunneler, then at any given point in time the client or the tunneler will send information to the server to be delivered to the end component.
Here we see the sequence of events that take place when a publish is initiated. As you can see, the user must instantiate PubSub. After PubSub is started, a connection is attempted to be established between the RabbitMQ server and the client. After, we declare the exchange that will distribute our messages. Once this is done, PubSub declares the presence exchange, which keeps track of who's entering and exiting the channel. Upon the declaration of both exchanges, the specified queue will be created. Finally, the user simply uses the publish method to publish a message to the messages exchange in the RabbitMQ server to the specified queue. Here, we have the flow of events for subscribing to a queue. As we can see, the sequence of events upon instantiation remain the same. However, upon subscription, the logic behind presence takes place. A binding is made between the queue we're subscribing to and the presence exchange with two routing keys. The empty routing key expresses our interest in hearing about bindings coming in and out. The routing key with our username allows all other users with an empty routing key binding to be aware of our binding. Once this is done, we simply bind the queue to the messages exchange with whatever routing key specified and then begin consumption. This will return a frame containing set amount of information, including the messages in the queue.
System decomposition for the tunnel software looks as follows. There is a server which awaits for incoming connections from the client software or the tunnel software, and that redirects any requested information or any data that needs to be delivered from the client to the tunnel or vice versa.
Here we have a high-level breakdown of PubSub. As we can see, a lot of the behavior discussed earlier is shown here in a more high-level fashion. This diagram shows users connecting and then being able to publish and subscribe to a specified queue. We can also see more clearly here that the messages exchange is what actually handles the distribution of our messages.
Here we see the system deployment diagram for the tunnel software. It consists of a middle device, which we can see is a server hosting the server software. Then we have two other devices that connects to the server. One is a client running the client software, and the other is the tunnel or the target running the tunnel software. On the client device, we observe that we also use either a browser, a terminal, or VNC client in order to communicate with the client software running on this device.
Here we have a breakdown of PubSub's deployment. Any client implementing either the web or the desktop solution will connect either via Stomp over WebSockets or TCP to the RabbitMQ server, which contains the plugins and the AMQP logic.
Tunnel security and privacy are within the structure of TCP connections, plus in addition all the security advantages and verification required by SSH session or VNC software credentials.
With PubSub, you must pass user credentials in order to connect to the RabbitMQ server. PubSub is also able to take advantage of the RabbitMQ's support of SSL authentication. In addition, users can specify who can interact with a certain queue and automatically delete queues if desired once no one is connected to them.
Design pattern for the tunnel software looks as follows. Reliant server concept was used in order to redirect connections from point A to point B, having a middle server taking care of this process. For PubSub, a publish and subscribe method was approached in order to reach multiple devices by just sending one message to a queue. Here we have a diagram showing the tunneler state machine of the server when receiving a client connection. It creates a new client item which then either finds an existing tunnel connection item or disconnects from a tunnel connection item, ending in a different state. The main algorithm of the server, or one of the most important, is when listening for new data coming from one of the available sockets. The select function checks for when there is any outstanding flag on any socket, and if it's read, means there is new data to be read. For all sockets that contains this flag, we remove it from the active list temporarily, and then we get the real socket object and put it in a ready queue which then is going to be taken care of by different threads that are listening to this queue.
Here we have the logic behind getting presence to work in PubSub. A lot of what we discussed earlier is seen at play here. Below, we have the actual interaction with the data received from RabbitMQ. Here, extracting not only the message, but who sent the message and what action was done by a user, either a bind or an unbind to a queue within the channel.
Now we observe sunny day and rainy day of testing for the tunneler software. On sunny days, we have starting SSH session. Purpose was obviously to ensure SSH sessions were starting correctly. The setup is having the PubSub agent running and subscribed to a queue. The input comes from the web. The expected result is having a new terminal open with the SSH session initiated. Result was as expected. Now, for a rainy day, we have server handling disconnections. Purpose is to check and make sure the server doesn't crash when other connections fail in the middle of a session. The setup was a VNC session running. Input was closing the VNC client in order to interrupt the flow of information and crashing the connection. Expected result, the server find the closed connection and drop it along with the other end of the session. The result was as expected.
This has been an introduction to Addigy4's project for the fall semester. Before we go, we would like to leave you with a video demo of both projects that work together. Enjoy!
As we can see, we have a PubSub agent with an ID, a queue name. Now we're creating a different PubSub agent with a different ID, a different user, and a different mailbox, which is going to be a queue. Once we have both instances connected to the PubSub server, we go ahead into the website. We choose connect from computer machine 1 and connect to machine 2, and we're going to start an SSH session. Now we can see a pop-up terminal will open with the SSH session initiated, asking for the password. Once the password was inputted, we can input any command to run on the machine. Now if we hit disconnect, the connection is going to close and we're going to see the exit status -1, meaning the connection was closed. Now if we pick a different machine, connecting from machine 2 to machine 1, and we want to initiate a VNC session, we see that it automatically opened VNC client connecting to the machine. If we hit disconnect, then the session will be closed again, ready to create a new one. Thanks for watching.